Hi everyone, welcome back to Insights Data Academy. This is our week 3 in our SQL Launchpad course. In this lesson today, we'll be discussing about join and its types, which includes the inner and the outer join. First of all, what do we mean by join clauses? Join clauses in SQL are used to combine rows from two or more tables based on a related column between them. The key point here is that for a join clause to work, you are combining rows together, one, and secondly, you are joining those tables on a related column. Take for instance, you have a database like this. Let's call this database 1, and we have several records or tables in there. In this particular relational database, each tables, let's call this A, B, and C, they are related by keys, the primary and the foreign key. Table A is related with table B with some key. Likewise, we can also have a relationship between table A and table C also together, or table B and table C, as the case may be. The key in each table is what gives the privilege of joining the tables together. Take for instance, when you have a table like this, let's say table 1, and another table like this, table 2, in the same database. This table 1 over here has some fields like the student ID, the names, and the score. Likewise, table 2 has some IDs, some fields like ID, department, and the student ID. Looking at this table 1 thoroughly, student ID here is the primary key for this table. Primary key are the unique identifier in a table. We have 3, we have 4, we have 5. However, looking at this second table, this table 2, student ID here, it's a foreign key because it's not the unique identifier for this particular table. The unique identifier, which is the primary key for this table, table 2, is this ID 01, ID 02, and ID 03. It's a primary key here in table 1, student ID, whereas it's a foreign key here in table 2. This key is what relates table 1 to table 2. So whenever we are wishing to use a join clauses or a join clause, we only join two tables that have some related column together. Let's take for instance, this table 1 has nothing in common with this table 2. We won't be able to perform the join operation. So for a two tables to be joined together, they must have a related column. You can join between two or more tables together, as we illustrated here in the first instance. Likewise, you can also join database to database. Let's take for instance, you have a database over here called database 1. You can join this database with another database over here. Let's say this is database 2, which has some records. Let's call this D, E, and F. You can join a record or a table here in database 1 to another table in another database, especially when you are doing some complex analysis. It may require you joining a data or a table from a particular database to another table being recorded in another database. So you can simply leverage on the join clause to achieve this. Let's move ahead to the types of join we have. Basically, there are two types of join in SQL. We have the inner join and we have the outer join. The inner join, it's a type of join that returns only the rows where there is a match in both tables based on the specified join condition. Another name for inner join in SQL is basically called join. Whenever you see join in a query without specifying, it means inner join. However, outer join on the other side, it returns all rows from one or both tables, even if there is no match in the other table. For inner join to work, there must be a match in the both tables, whereas the opposites might be the case for outer join. But for inner join to work, there must be a match in both tables. And there are several types of outer join we have. There we have the left join, we have the right join, and we have the full join. Let's look into how this is being used in SQL. Starting with the inner join, as we made mention earlier on that the inner join only join rows that match in both tables. Looking at this first and second table that we have over here, this table 1 has some rows here like row 3 and row 4 that correspond with some rows in the second table, that is the table 2, like these 2 and these 3 and 4 over here also. These two rows match together, the row 3 and 4 here and the row 2 and 3 over here. So when you use inner join in your query to join these two tables together, you get a result like this below. You only have those rows that match together in the first table with the second table. Take for instance this first row over here with student ID 3 joined with this second row in the table 2, student ID 3, and the result is what we see below. That is, we have Abdul and anatomy with the corresponding departments. The name is Abdul, which is here, while the department also its anatomy, his department is anatomy. Likewise, when you look at the second row here with student ID 4, the name of the student is Ola, and you can see Ola over here, while his department is medicine, which is corresponding to the third row in the second table. The inner join only joins the rows that match in both tables. The remaining rows, like row 3 over here with the unique identifier 5, and the other first row over here in this second table with student ID 2, was not in our join table, simply because we are simply using the inner joins. The inner joins only join rows that matched in both tables. Other rows that are not matched won't be joined using inner join or ordinary join in SQL. So let us move ahead to the other types of join, which is the outer join. Here we'll be looking at the left join. Alright, left join is quite different from inner join. Our left join joins all rows from the left table and the matching rows from the right table. We have table 1 and table 2. Left join, that is the table being specified before calling onto the left join clause. Take for instance, you are writing a query. Let's say select from, let's say this is a student table. We can select all or select everything from student table. Then join, left join it. Let's say left join. Let me clear this. Let's say left join with another table. Let's call this table department table. Like this, for instance. This first table over here, the table being written before using this left join is called the left table. Why this table being specified after the left join is the right table. So when you're executing this query in MySQL, MySQL sees the first table being specified after the from clause as the left table, while the table being specified after the left join as the right table. So as you can see here, our left table here is this table 1 over here, which is the students table. In the students table, we can see some entries like this first entry, second and third over here. We have the student ID, the name and the score. Why this second table over here, that is the department table, we have the student department like mechanical, anatomy and medicine. When you use left join over here, all the entries, that is all the rows here in the left table, will appear in the joint table. Take for instance the student ID 3, we can find it here in the joint table. Likewise, the student with ID 4, we can also find it over here. Likewise, with the last student with ID 5 is also appeared here. when you use left join retrieves all the rows from the left tables and match it with the corresponding rows if there's any in the right table. Looking at the match with the right table over here, the student ID number 3, his name is Abdul, while his department here is anatomy. We can see that they both appear over here. Whereas, and also, students with ID 4, his name is Ola. Ola also appeared here, and his department, which is 4, also appeared here. However, the last part, the last row, the students with ID number 5, Said also appeared here. However, the department, row 5, student ID 5, is not in this second table over here. We only have students with student ID 2, 3, and 4. Nothing like 5. So we can't find their departments. Since it's not matching with, as in the entry here, the row here is not matching with the row in the other table, MySQL return null. That is, it doesn't see it. It doesn't recognize the entry. So for any unmatched row, whenever you're using left join, it returns null. If that is clear, let's move on to the next outer join, which is the right join. Alright, right join, just like left join, they are just opposites. Instead of retrieving all the rows in the left join, they match to the corresponding row in the right join, and whenever they are not matching, it returns null for for the left join. The right join is the opposite. For right join retrieves all rows from the right table and match it with the rows from the left. Take for instance our table 2 here. We have the department, which is the department table. We have students with ID 01, ID 02, and ID 03. When you use right join with this query, let's say our query looks somehow like this. Let's say we are selecting the name and department only from the right table here is the table 2, right? From table 1, right join it with table 2 on the unique ID or the related column that relates table 1 to table 2 together. We can simply alias this. Let's say from table 1, let's alias it as let's say T1, y table 2, let's alias that as T2. We can simply say, okay, join it on the corresponding related column, which is the student ID. Let's say T1 dot student ID when it's equals to T2 dot student ID. So let's imagine that this is our query that gives this join table results. This first table here is our left table, as we explained earlier on, why this is our right table. That is the table being specified after the right join. However, when MySQL wants to interpret this query, since we've specified the type of join to be a right join, it retrieves all the entries, all the rows here in this table 2. Take for instance, in this table 2, we have students with ID number 2. You can see it in our right join table, the results 2. Another student with ID number 3, it also appears here. And likewise, the last students with ID number 4, it also appeared here. We can simply put an ID here. Or we have to specify that this, let's say, let me just adjust this. Let's say this is from the table 2, which is T2 bar. Let's say T2 dot the table 2, T2 dot student ID, then underscore, then we can put our select over here. This is just an illustration. This has to display student's ID or something like that. All right, as you can see from here, this table 2, all the entries in this table 2 appeared here in our results, in our joint results. However, some of the entry in table 1, like this third entry here with student ID 5, doesn't appear. It's return null for the corresponding value of that student. Student 3, which is Abdul, appeared here with his department, corresponding department, anatomy, right? Likewise, student 4, Ola also appeared here with his corresponding department, which is medicine. However, the last table here, which as in the last row here, which is 5, doesn't appear at all, just because it's not matching with table 2. Whereas also for this table 2, the name of the student doesn't appear. It appears as null. That is, it can't find the corresponding match of table 2 here right in table 1. A student ID with 2, it doesn't find it over here, so it returns null. Let's move to the last type of outer join we have, which is the full join. The full join, as it implies, it maps out all rows from both tables. Even though MySQL doesn't have it directly, but there's a workaround behind that of achieving full join using full join in MySQL. But what it does is that it maps out all the rows from the first table with the second table. In this first table over here, we have students with ID number 3, 4, and 5. In the result, we also have 3, 4, and 5. Likewise, here we have 2, 3, and 4. We can also find out that there's 2, there's 3, and there's 4 over here also. All the entries in the table will appear right in the join table. That is, MySQL will retrieve all the rows from every table in the query. However, for those tables or for those entry that doesn't have an image in the second table, it will return null for them. Take for instance, we have in this student ID in this table 2, from mechanical, we can see the department also showed mechanical. But the name of the students, there's no students with entry 2 here, as in with student ID 2 in this table 1. So for that, it doesn't return anything. So it returns null. Likewise, for these students here, the students with student ID 5 doesn't appear in this second table, that is the table 2. For that, so it returns null for that. Comparing any row in a particular table with the second table, if the entry has a corresponding image in the second table, it displays it. However, if it doesn't, it displays null. So that's that for join. We made mention of types of join we have, like the inner join and the outer join. And we also discussed about the types of outer join we have, like the left join, the right join, and the full join. Another name for left join is called left outer join. Likewise, right join is also called right outer join. So in our next class, we'll be discussing how to use join on our MySQL workbench. Thank you for listening. See you in the next class.